Hello everyone, so today we'll look at this question, we go sort. Given the integer array nums, reordered such that nums at index 0 is less than or equal to nums at index of 1, greater or equal to nums at index 2, and less than equal nums at index of 3, and so on. So we assure that the input array always has a valid number. Great news. Okay, let's look at example. So the input nums 352164, the output according to this law, the Wiggle law. So 3 less than 5, greater or equal to 1, and less than 6, and also is greater than 2 and less than 4. This also works. 1 less than 6, greater than 2, and less than 5 or greater than 3 and less than 4. Okay, it also follows. That means actually sometimes we have different output, but they also works. So the second example is 665,638, and we see that this 6 is smaller or equal to 6, and larger or equal to 5, and less than or equal to 6, and larger or equal to 3, and less than or equal to 8. So it actually also works. So we all know what kind of role it is having. So we have to make the output as the kind of wiggle order. All right, so the constraint is here, and it's guaranteeing there should be an answer. So probably we don't really need to handle that much of edge cases because I don't think there's so many edge cases here. In the only exception probably gonna be the nums. So if we have different kind of nums, right? Okay, but except that, I think it is pretty straightforward. All right, so there are actually several ways to solve these questions. So the first way is the most intuitive, also brute force. The first way is using sorting. So no matter what kind of sorting techniques we have, but I mean most commonly it could be like merge sort or quick sort, and after sorting, we can swap the adjacent I mean, like or I mean, just like let's say, look at this example, like swap the adjacent elements, or let's say one, sorry, 1, 2, 3, 4, 5, 6. Okay, so we swap. 1 is less than or equal to 2. This works. This is fine. We stay here. But go to the next. 2 is less than 3. This doesn't meet the condition. So we will swap 3 and 2. Now 2 is here. So 2 is less than 4. It works. But 4 is less than 5. It doesn't work. So we swap these two. And so 5 becomes the first and 4 comes later. Okay, so this actually works. And what's the runtime? Because this kind of techniques actually only takes, I think it's only like roughly 3 lines of code, but the runtime is not so great. The runtime, what's the runtime? Let's analyze it. So I think mainly the most costly runtime here should be the sorting part, because most commonly sorting is big of log n, I mean n log n. So the overall would probably be big O of n log n in this case. Also, we need to notice that we probably need to also need a for loop when we are swapping. But that's big O of n, so it's less than n log n. Overall, it's going to be n log n. And we see here, there's a follow-up question. Could you solve the problem in big O of n time complexity? Okay, so that means there should be a better, or let's say optimal solution. So what's the optimal solution? Look at this complexity. It's a big O of n, so that means we shouldn't sort. We shouldn't sort, and it should be a kind of for loop, and it shouldn't be any nested for loop inside. It should be like a one-time for loop, or could be parallel for loop as well. But here, let's think about a greedy approach. All right, we have a big O of n, so why not think of greedy approach? What kind of approach can we have? So speaks of greedy, we need to think what kind of greedy thing we can do here, right? So how to really maintain the kind of legal structures? Let's look at some examples. Okay, so here is going to be greedy. Okay, for example, just like I'll just make it more general. So A less or equal to B and less than equal to C. All right. So this doesn't work, right? B should not be less or equal to C. So now what should we do? Why not we swap this, right? Just as we did here. So A less than equal to C and greater or equal to B. It works, right? So C becomes in this and C we move C to this position and move B to this position. Now, does the kind of inequality still holds? Of course, this doesn't change anything. A is less than B, so and B is less than C. So A must be less than C, or I mean equal if if A, B, C are equal. But it holds for this part. What about this part? It also holds because we see B is less than or equal to C, so C is greater or equal to B. All right. So at this point, if we are really thinking it algorithmically, there might be a problem, right? So people may ask, what if there is a D? What if there is an E? All right, let's look at an example. So, okay. So we still have it here. Okay. So what if there is an E? Right? And okay, if the E, or I mean, this case, we look at D first. So what if there's a D? Okay, so if that's in this kind of shape, then it doesn't matter because we'll just keep it, right? We keep it is less than equal to D. Nothing has to be changed. But what if the D is actually smaller than, okay, let's look at this. So what if the D is instead of greater or equal, what if the D is less than or equal to B, right? Okay, so why not we do another change? We do another swap. So now we swap D here and B is here. Okay, so the sign becomes here. Does that make sense? Okay, the previous two, A and C, relation still holds, so without any further explanation. But here, there's actually nothing, fancy here. We just change the order. And D is still less than C, or I mean equal to C, because D here is less than or equal to B, and B is less or equal to C. So this relation makes sense, does make sense, right? All right, so that's why we can use greedy here. Because we actually really need, what we really need to do is really to look at the two adjacent elements and swap them. So that's how we're gonna do for these questions. But before we write the code, we have to think, when should we swap, right? So there are two kind of scenarios. One is we look at odd positions, right? Odd index. So starting from 0, it's going to be 1 and 3, right? And so on. So for odd index, we compare the odd this number to the previous ones. So if this one one is the number at index 1 is what? Is greater than the number at index 0, we keep it. But if it's smaller than the value at index 0, we need to swap it, right? Also for the numbers at at even positions. So look at 2. Okay. What's the condition for the even index? Okay, so if 2, right? If 2 is greater than 5, obviously it is not here, then we need to swap because the condition does not match. We have to swap it so that the condition holds. All right, so that's 2 conditions. Let's jump into the code. So in the beginning, let's do a for loop. So for I in range, we need to start from 1 and length of nums, which is the input. Okay, so what should we do here? If we need to know if it is in, let's say, odd index or even index, right? So if I is modulo, where's modulo? Modulo 2 is what? Is 1. Then that means it is odd. So we'll do something for odd. Okay, else? That means we'll do something for even. Okay, so what should we do for odd? As I just said, the condition that does not satisfy the odd is if nums at index of I is what? Is smaller than nums at index of I minus 1. Then we do swap. Okay. Also, for even conditions, if nums at I, right, for even conditions, it should be smaller. So if it is greater than nums at index of I minus 1, then we do the swap. Okay, keep in mind that actually here we need to do in-place swapping. So what is in-place? In-place means we don't really create something new. So we replace it, we swap them directly. Okay. So here, what's the in-place algorithm? So it's actually quite simple to implement here in Python. So nums of I and nums of at I minus 1, we just swap the orders. So I minus 1 and nums I. Okay, it's exactly the same here. Okay, so we don't have to return anything. Let's try. Okay, it's accepted. Let's submit it. Okay, nice. So before we go, what's the runtime, right? So here is a for loop. Keep in mind, this in this algorithms, we didn't do any sorting. Sorting is for the previous intuitive way, but here for greedy approach, there is no sorting. So as we said here, it is big O of n. All right, thank you so much.